This is lesson 4A, your second review video for symmetry and surface area. And this video is going to review how do you find area of rectangles, how do you find the area of a triangle, and how do you find the area of a circle. Some of you have these notes, and some of you it would just be a good idea to watch and review this lesson just so you're familiar with everything before we move to surface area. So just a reminder of what area is. So area is the amount of space that a shape takes up. When we are talking about area, we are talking about two-dimensional measurements. So we are not talking about the 3D measurement. We might be using a 3D object, but we are looking at the flat sides of that object. So all of those flat sides together will make the surface area. So when we measure area, it is a two-dimensional measurement, and so the measurements are to the power of 2. The squared says it's, right? It even says squared. So it's the measurement as if it were a shape of a square or two-dimensional instead of a one-dimensional measurement like a length. Area is the result of multiplying two one-dimensional measurements together. So meters times meters, centimeters times centimeters, inches times inches, and we use the words like length and width and base and height to describe those different measurements. So taking you way back, the first way we learned to calculate area is we said draw a shape on grid paper and count the squares. So on the first one, we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area is 12 units squared. Later on, we started to tell you, well, you can actually look at the side lengths. And if you have 3 units by 4 units, 3 times 4, you get 12 units squared of area. If we look at the second shape, we counted 1, 2, 3, 4, 5, 10, 15, 20, 25, 30, an area of 30 units squared, or 6 units by 5 units. So 6 units by 5 units gives us 30 units squared. Or the last example, I hope you recognize that it is a square. It is 3 by 3. So you get 9 units squared, and reminder, 9 was one of our perfect squares. I hope you remember that. And so that was where we started out. And then we started saying, well, we're actually going to use a formula, and we're going to say that the area, so the amount of space that this rectangle takes up, can be found by timesing the base and the height. So base and the height. So the area is 12 centimeters squared, keeping in mind that we need to include our units. Okay, or if we look at this larger rectangle, area equals base times height again. So base of 24 centimeters, a height of 8 centimeters, and I could also use length and width if I wanted to. It doesn't matter. As long as I take the 2 side lengths and multiply them together. We get an area of 192 centimeters squared. And so then we moved from rectangles and squares and we started looking at triangles. And we said, well, if you start with a rectangle, to find the area of that rectangle, you're going to go base times height, or length times width. And we said, actually, what a triangle is a triangle is half of a rectangle, right? Because we can fit 2 triangles into one rectangle, so one triangle is half of a rectangle. So to find the area of a triangle, you would find the area of a rectangle, base times height, and then split it in half, divided by 2. And if you want to write it out, base times height divided by 2, all linear, or if you want to turn it more into a fraction, either way it doesn't matter. You're still going to multiply your base and height and then cut it in half.
Mr. Tron, could you please contact the office?
Still at school. Okay. And so when we're looking at these, it's important to keep in mind that we don't use any slanty heights. When someone asks you how tall you are, you don't lean over and say, okay, now you can measure how tall I am. We always want to use the base and height that are perpendicular to each other. So they're at the 90 degrees. They meet like two straight lines crossing each other. Neither of them is slanted. And so we have a base of 8 centimeters and we have a height of 9.5 centimeters. If we look on the second triangle, again, the 90-degree angle is actually already drawn in there for us. And so the base is 6.5 centimeters and the height is 4 centimeters. And so if we were going to find the surface area of each for triangle A and triangle B, triangle A base we said is 8 centimeters. The height is 9.5 centimeters, and we go area equals base times height divided by 2. If you notice, my equal signs are lining up, my areas are lining up. This just keeps your work neat and organized. And so when we go 8 times 9.5, we get 90.25 centimeters squared. And then we divide that by 2. And so we get a final area of 45.125 centimeters squared. And yours should all be on one straight line. I ran out of room. When we look at the second example, we have a base of 6.5 and a height of 4. So the base is 6.5 centimeters. The height is 4 centimeters, so area equals base times height divided by 2. Yes, you need to write your formula every time, so no, don't even ask. So we get area equals 24 centimeters squared divided by 2. So the area is 12 centimeters squared. Hopefully that is a nice, easy review for you. So those of you that have the Lesson 4A notes printed, you have 2 additional pages. They're big, tall pages, so I've left you lots of room to show your work. Oh, I lied to you. There's one more that I want to show you. I am going to go through the circle calculations with you, and then the last page you're going to do by yourself. Sorry, my bad. So, lastly, to find the area of a circle, we use the formula area equals pi times radius, or area equals pi r squared. And so A is standing for the area of a circle. R is the radius of the circle. The radius is also half the diameter. And this is pi. And 3.14 is the number we use, but we are using the pi button on our calculators to have a more precise value. Pi is one of our irrational numbers, so it is a non-terminating decimal and it does not follow a pattern. People have tried to find the end of pi and they haven't. Okay, so our first example is given a circle. It has a radius of 8 foot, which means the diameter, so the full way across would be 16 feet, but we only want the radius. And so to find the area, we're going to go radius times pi, or pi times radius. So pi times 8 feet times 8 feet. Notice that we wrote the equation down. You don't have to show this step every time, but you have to show me a step every time. If you feel more comfortable writing that out, then you can. So I type into my calculator and I get 201.0619 . So we're going to round that to the nearest whole. So 201 feet squared. And that's it. For the second one, I have given you the diameter of 9 feet. In order to find the radius, we need to cut the diameter in half. So we're going to go 9 feet divided by 2, and we get 4.5 feet for the radius. So now when I go to find the area, we're going to go pi times 4.5 feet times 4.5 feet. Keep in mind that 4.5 squared is not the same as 4.5 feet times 2. Okay? These are not the same. So no, you cannot use the diameter instead of the radius. When we use pi times radius, we get 63.61725, which gives us 64 feet squared, right? We look to the, if we're rounding to the 3, we look to the 10th place, and the 6 is larger than 5, so we round up. Your last example that we will do together is area equals pi r squared. So area equals pi times 10 centimeters squared. Remember, the squared is outside the bracket, so it applies to everything in. So area equals pi times 100 centimeters squared. 10 to the power of 2 is 100. And centimeters to the power of 2 is centimeters squared. So when we multiply these, we get 314.159 centimeters squared, or if we're rounding to the nearest whole, the 1 tells us to round down, so we get 314 centimeters squared. Now you are going to, if you have the 4A notes, flip over, and I have 9 examples for you that I would like you to calculate yourself. So you may need the diameter or you may need the radius. You need to decide that for yourself based on the examples we just did. And I will be checking these in class on, I'm going to say Thursday for you. So you're going to have 2 classes to work on it, okay? Please make sure you're filling those in. I want to see your formula written down. I want to see your calculation. I want to see your answer with correct units.